Hi, boys and girls. We're recording a couple videos this week on multiplication and multiplication algorithms. And the first one is going to be on the traditional method. And we've been using the partial products for the first portion of this unit. And I know a lot of you are already familiar with the traditional method, but this is going to be something that's worth still watching and still being kind of just familiar with the steps and how it relates to partial products. So let's take a look at our first problem that I'll be coming up with off the top of my head. Let's say we're going to do 36 times 72. Now, with the partial products, we're going to do the same format as traditional. We're going to write it out like this. And you could potentially do the little partition rectangle too. It's a really good, useful way to make sure that you have all of your partial products. But we're going to jump right into the partial products method, so just so we can kind of see what it looks like. So we have 30 times 70. We have a 30 times 2. We have a 6 times 70. And we have a 6 times 2. So you can see, and I'm just going to use some color coding here. You can see that this 30 here is multiplied by both the 70 and the 2. And you can see that this 6 here is multiplied by the 70 and the 2 as well. And we want to make sure that every single place value is multiplied by the other number. And notice how this 30 is not multiplied by the 6 at all here. So because they are on the same team, right? So anyway, let's get into actually solving with the traditional method. And then we'll go back and look at the partial products and see how close it aligns. So we're going to have 36 times 72. And there we go. Now, you know what I realized? I think I'm actually going to go back and I'm going to color code a little bit of this. Okay. So I'm going to do 36. And then I'm going to choose a different color for each of the numbers here. So I'm going to go with orange for 2. And I'm going to go with, I'm going to go with green for the 70. All right. And then I'll do a black for the line here. Okay. Uh-oh. Getting a little glitchy. All right. Anyway. So let's get back to that orange. We're going to multiply with traditional. We're going to multiply the ones place of this bottom number times both the ones place and the tens place and any other places before we multiply onto the tens place of that bottom number. So let's kind of show you what I mean. So we're going to do 2 times 6 is 12, all right? And we're going to carry the 1 from that 12 and put it up above the 3, just like that. And then we're going to multiply the 2 again by the tens place. And we're going to have 2 times 3 again. And we're just thinking about them as single digit numbers. So we're going to do 2 times 3 rather than 2 times 30. But when we place this number, we're placing it really in the tens place. So that is essentially how we keep the tens of the 30 in the right place. So we're placing it right here in sort of the tens place. because when we look at these numbers, we've got the ones and we've got the tens, and there's probably going to be some hundreds here too. So anyway, 2 times 6 was 12 ones, right? And now we're going to do 2 times 3 tens plus 1 extra 10. So we're going to do 2 times 3 is 6, plus 1 more 10 makes 7 for 72. So 2 times 36 is 72. That makes a lot of sense. Now, the next number we're multiplying is this 7. And that's not just a 7, it's a 70. So we're going to multiply the 70 times the 36 as well. And we're going to start by multiplying the 70 times 6. 6 times 70, right? And since this is a 70, we are going to be placing that first number we have in the tens place, which means that we really have 0 ones for this next row. And that's what we're going to be doing here. So we're multiplying this first row here was all the numbers that we multiplied by this 2. And this next row is all the numbers we're multiplying by the 7. So we're going to do 7 times 6 is 42. And we're going to put 2 tens there. And we're going to put 4 up here to say that we have 4 extra hundreds, actually, because that's what is going to be going to this next place. So 7 times 6 is 42. So we're going to put the 4 up here. Now we're going to multiply 7 times 3 and then add 4 more on top of that. So 7 times 3 was 21, plus 4 more is 25. Now, our last step is adding up all of the numbers. And so we have 2 plus 0, 7 plus 2 is 9, and then we have 5, and we have 2. So in total, we have 2,592. Okay, so let's test that. Let's compare that to this problem here. Let's see how close we get to the same answer. All right, so we can work our way up or down, doesn't matter. We can do any of these as long as we add them up correctly at the end. So 30 times 70 is 2,100 or 2,100, right? We have 2 zeros that we're extending the basic fact of 3 times 7. And then we have 30 times 2, which is 60. And then we have 6 times 70, and that is 420. And then finally, we have 6 times 2, which is 12. Oops, and I realized I'm off the page there. So afterwards, we're going to add it up. And I'm worried I might actually run out of space there, but let's test it. So we've got 2. We've got 6 plus 2 plus 1 is 9. We have 1 plus 4 is 5. And we have 2. And look, we've got the same answer. So that checks out. But let's check it out a little bit more. Let's take a look at how this set of numbers that we are working with is very much like the set of numbers here. We have 72. Now, if we look at this and that, we can see that both of the numbers that have the 2 as a partial product combine together to make 72. It's 60 and 12. And then we also have the numbers that have the 70 in them. They add up to 420, 2,100. They add up to 2,520. So we can see how this traditional method is still doing the same work that the partial products method is. It's just kind of broken down into smaller chunks. It's a little bit more clear about what each part of the problem is worth. But in the end, it isn't necessarily going to be the most efficient. So we do want to graduate to this method. So let's take a look at another one that's going to be a little bit bigger and a little bit more of a challenge, but I think we're ready for it. Let's use purple, and I'm going to say, 548 multiplied by 67. Okay. Now I chose different colors just so we can kind of visualize this a little bit. And I want you to give this one a try. Okay. I want you to remember to multiply first the ones place by each one of these digits in the top number. And then we're going to multiply the tens place by each one of these digits in the top number in the next row. And we are going to need a 0 for that second row. So I'm already kind of drawing this in like that for you. Okay, so work on this, try to solve it, and when you're ready to test your answer, press play and see what happens. See if you get it right. All right. So let's take a look. I'm going to use blue for the 7, all right? And we're going to do 7 times 8 to start. 7 times 8 is 56. And so we're going to carry the 5. We're going to put that above the tens place. And we're going to keep the 1s there. And then we're going to do 7 times 4, or 7 times 40. And that is 28 plus 5 more makes 33. And then we have 7 times 5, and that's 35, plus 3 more makes 8. There we go. Almost made a mistake there. All right, so now we're going to multiply the 6, which is a 60. So we're going to start that first numbers in the tens place, and we're going to multiply by each one of these digits in the top number. I'm going to cross out what we worked on from the last one. So 6 times 8 is 48. We're going to carry that 4 from the 40 and add it to the next number. 6 times 4 is 24. Add the 4 to 24 makes 28. And then we're going to multiply 6 times 5 is 30. Add 2 more to make 32. Uh-oh, glitchy glitch. All right. Oh boy. Well, anyway, that was quite something else there. I think my pen tool got a little glitchy there. All right, so let's add it up. And we've got 6 plus 0 is 6. And then we got 3 plus 8 is 11. And then 8 plus 8 is 16, plus 1 more makes 17. We've got 3 plus 2 plus 1, which is 6. And we've got 3 more. 36,716. Now, we can check our work with a few different things. We could check our work with partial products. We could even do the partition rectangle, test ourselves that way. But this is going to be a method that we get into the habit of using more and more and more as we get comfortable with it. And stay tuned. you are going to watch another video soon on the lattice method. And that method is also something that I trust as being a very efficient method, but it does require some very careful drawing. All right. Anyway, I hope this is helpful, and I hope that you can give this a try and start feeling comfortable with it. But most importantly, let's keep practicing our facts. I am going to be giving you some math fact practice very soon, and it is going to definitely be useful for us to become experts in multiplication and eventually division. All right. Hope you're doing well, and I look forward to seeing you soon.